Welcome back to another exciting episode of The Executive with Meg, the Gulf Leader Circle podcast that brings you exclusive conversations with the top business leaders in the GCC. Today, I'm joined by the technical director and co-founder of Falcon Oilfield Services, Mr. Fouad Ibrahim. Very, very welcome on my podcast today. It's such an honor to have you.
Thank you, Megan. Thank you. It's a very interesting podcast that you've been doing, and I hope that we will find topics that will add value to your listeners.
It's greatly appreciated.
Thanks
and I want us to dive right in. So walk me through your journey from obtaining your degree in electrical engineering to becoming the technical director at Falcon.
Wow, that's a question that I can take days to answer. I'll try to be brief. So, I finished my degree in King Fahd University, Petroleum and Minerals.
Okay.
And it's not like the United States, we have Ivy League universities, but you can say that there are an equivalent universities in the region that are called Ivy League. So KFUPM in Dhahran, where I went, is one of them.
Of course.
Sultan Qaboos University in Oman is one of them as well. So I finished electrical engineering and then applied to work for an international oil and gas service company. It's actually the leader in this industry.
Mm-hmm.
It's called Schlumberger.
Yes.
And the reason why I wanted to join them because they had branches all over the world, and I wanted to travel and get to see other cultures and experiences and so on. So they posted me to India, and I worked in India for a year.
Okay. How was your experience in India?
It was amazing. The first, India is such a diversified country. So many languages, so many religions, so many cuisines, nature, and so on. So I started actually in Calcutta.
Okay.
And I remember that year because it was the year Mother Teresa died, and I was actually in the funeral at that time.
You're kidding. You were at Mother Teresa's funeral?
Yes.
Oh my goodness.
And then after that, I went to the north. It's called Assam Nazira, and then back to the south to a place called Rajamundry. It's part of the state of Andhra Pradesh. And then I was fortunate to be transferred to Saudi Arabia, to Khobar.
Okay.
And in Khobar, I spent 4 years. During the 4 years, I met my business partner and my friend Zahran Al-Aufi, who is an Omani.
Yes.
And then one day he said, "Why don't you come and visit my country?" I didn't know much about Oman, to be honest.
Yeah.
But I said, "Okay, why not?" And when I came to Muscat, from the first minute I landed until the time I got to the hotel, everything was falling into place for me to fall in love with Oman, actually.
Yeah,
and then we were having a chat and brainstorming session about our observation of what's happening in the industry. And we both made a comment that technology is no longer a barrier for companies that want to do the service, because before the end of the 90s, it was restricted to the big three or the big four.
Okay.
I mean, I'm talking about Schlumberger, Baker, Halliburton, and Weatherford. But then companies that are independent started developing technology independently, but they wouldn't deliver the service. So there
was a gap there.
But the service companies have no barrier to access technology because it became now a new trend. Before it was the same company making technology and doing the service. So that observation led us to pursue this opportunity, and we were met with, when we proposed this to the leadership in companies like PDO, Petroleum Development Oman, and others, and I have to register our gratitude for their encouragement to go on with this. The first reaction was, this is unheard of, a regional or a local company that can do this high-tech kind of service. And they said, if you can do it, then okay,
Amazing.
And the third thing that we got good support also from the technology maker. So I say the stars were aligned for us to start.
Yeah.
And we started. We met with a lot of challenges and successes. Maybe we'll talk about that later. But then I was entrusted with the task of getting the technology together, the right technology for our application, for our customers. And that was my role. From the beginning, I was a technical manager. So I was handling the relationship between us as a company and the technology makers, be it in the United Kingdom, in the United States, in Canada, Russia, China, and so on. Put these technologies together to, a setup that they can be in synchronization and harmony, and they can work together. Because that is not easy when you get different parts from different places.
Of course.
So that was my task. And also to man the deployment of these technologies in the field and train the people, our people that we recruit to deliver the service. So I went from technical manager, was in the field most of the times in the first few years until things started stabilizing, we started growing. I took over the operation management job for a year, and then I started managing the new projects. One of the projects was to introduce the explosive services, which is before Falcon, it was only done by the international companies. We were the first local and regional company to have an explosive license.
So the first locally and regionally.
Indeed, yes.
What an achievement.
And then after the project manager, tenure for a few years, I took over the technical director job to continue to build on the technologies, the competency of our staff, the systems that we have in place, and software and digitalization of our operation and services.
And where exactly did this passion for these unique and advanced technologies come from?
See, I'm an engineer by upbringing.
Of course.
And I was always fascinated with the new technology. And one of the reasons, apart from joining Schlumberger, that it's an international company and I can travel, it was also they were always at the technical edge. They're having the technical edge. And, finding an opportunity or starting a company that is built in its core on technology was my passion and dream, if you like. And I continue to every day to look for
boundaries
to push the boundaries and look for new technologies. And guess what? Another thing that started emerging in the market is that independent technology makers with only one single technology, but it is a game changer technology. And we go and scout for it. We find it. We find the application for it. We bring it here. We show it to our customers. They like it. It adds value to their operation. And then it becomes a unique service that we are offering that is keeping us ahead of the rest of the pack.
And like you previously mentioned, since Falcon's inception, you've most definitely been confronted with several challenges and hurdles. Can you elaborate on these and how have you overcome them?
The biggest challenge at the beginning was the acceptance from the industry.
Okay.
Because they have been, for decades and decades, used to this particular high-end service provided by the big internationals.
Yeah.
And these are huge organizations with deep history and R&D budgets.
Exactly, and a proven track record.
And proven track record and systems in place, training and upskilling, architecture or structure. And then every time we go to do the job, the first reaction will be some uncertainty or skepticism even.
Yeah.
Whether we can, as an independent local company, pull this off.
Yeah.
So that was a huge challenge. I must say that it took us years to overcome. And the only way was to continue to do a good job and prove that if we are not better, we are not worse. We are at par with what they do. And actually, in many circumstances with many customers, there are key performance indicators, and one of them is the service quality. Because at the end of the day, we are a service company delivering a service. And service quality-wise, we were actually doing better.
Amazing.
But by consistently keeping that performance, we managed to, do this paradigm shift in perception of our customers.
And build a trust and the
Build
brand
that
identity and
trust
name
and
within-
confidence.
in the
And
region.
yeah, and I'm glad to say that Falcon became a brand that is associated
100%.
with reliability, quality, excellence, and also some pride. We have that pride in what we do.
No, it's very clear to see as well.
Thank you.
And besides the challenges, of course, you've also celebrated several success stories and victories. Can you share some of the success stories with our listeners and our viewers?
Yes, one of the successes that I am really proud of is the HSE performance of the company. We just celebrated 15 years of LTI free, and this is a remarkable achievement.
15 years?
15 years. And,
Wow.
I say that it came actually from a challenge at the beginning, which is to build the culture in the organization.
Of course.
That, accidents are preventable. If the right measures are taken, if the right training is given, if the belief is there, we empower our staff, our people, our engineers to stop if there is a risk, if there is an exposure to HSE. We will not tolerate or encourage anybody to carry on, do the work, knowing that there is some kind of a danger looming around.
Of course.
So that culture, also part of it, also the leadership, visibility, presence, and that's what we talk about to them when we go to site visits. We ask about their well-being. We show them that we bring them to the field.
You're not just a number forgotten
not just a number. We want them to go back to their families, accomplished and successful and safe, of course.
Safe, yeah, that's the most important
Most
part.
important.
Yeah, you have to return home.
I tell you, we stayed away from a lot of opportunities to work outside Oman because of this worry or concern about the safety and security of our staff.
Of course.
Yeah.
Ultimately, you have to be able to guarantee.
And also we invested in technologies that will make them safer all the time. One technology that I worked on personally was to use a safe detonating system for the explosives.
Can you repeat that, please?
It's a safe detonating system. So most of the accidents when you handle explosives is when you start the detonation.
Okay.
And the system we invested in was a new technology, and it proved to be very successful. And it was an extra mile we walked just to make sure that our staff are always safe and protected.
And you said that you personally worked on this technology.
Worked on not developing it, but identifying it and bringing it, training
Into your
our guys
company.
on it, and persuading the board to invest in it and not to use the conventional lower cost alternative. Yeah.
So, of course, with Falcon specifically, within the oil field sector, it's a very competitive market. We all know this. So how are you staying ahead of the curve by embracing these technologies? And also, can you elaborate on these unique technologies?
That's a great question. You see, as I said, we first, being from the country, from this place, we know the challenges. We know it very well because we are the sons of the land, if you like. And we are technical people who understand these challenges.
Of course.
And this is what we've been looking at throughout the journey. I will mention three specific technologies that are close to my heart and also very unique to Falcon. And we are leaders in it. So one of them is in the steam injection profiling, which is related to the production of around 15 to 20% of the Oman production. This is a field in the south of Oman called Mukhezna, where actually imagine that in some places the oil is so heavy, it's like called butter. You need to to bring heat to it in order for the viscosity to reduce.
Okay.
Like we do with the butter, you heat it, it becomes liquid and it starts flowing. So there was no technology that can do the assuring where the steam, this heat is going into the underground layers. And that's the technology we developed. Another technology that we adopted earlier on is something related to the increase of productivity of the same wells. So in order to produce, you need to perforate. And perforate, it can use conventional or some kind of reactive liner. A third one we have also pioneered in the region is the oriented perforation, where you have sometimes fiber optics deployed in the completion. Fiber optics, we know about it because we use it in telecom, in your house, in the broadband.
Okay.
But the fiber has other applications. You'll be surprised.
Okay.
Maybe we can talk about it later. But what we do is to be able to shoot the explosives away from the fiber optics line. So these technologies that are keeping us ahead, and we continue to do the same with others.
So I want to deep dive into these three technologies because, like I mentioned to you before we started recording this podcast, these are all terms that I've never heard of, and I quite frankly do struggle to even pronounce them. But with regards to like the reactive aligner perforation, can you walk us through the process? How is it related to well productivity, etc., so that we can maybe make it more understandable for our viewers and listeners at home?
Okay, I'll try to simplify it. And this is something that I have to do when I talk to newcomers who are coming to the company, because I conduct a lot of the training. And also when I talk, for example, to bankers or finance people.
Yeah, it's something that we're not aware of. Like I said, even the pronunciation gets me tongue-tied.
Yeah, so quickly, when you want to produce, first thing you do is to drill the well.
Okay.
When you drill the well, after you drill, you have to run a pipe, a steel pipe. It's called casing, to keep the well in its shape for as long as it lives. And you pump cement, similar cement we use in the construction. You pump it behind the casing. So now, the reservoir, the rock that has the oil, will not be able to produce unless you make a connection between the borehole, the inside of the well, and the rock. And how do you do that? Is using explosive. You go to the right depth, and you make this tunnel or hole. So it penetrates the casing, the cement, and it goes into the formation, and the oil starts flowing.
Okay, that's a lot more understandable.
Is it? Okay,
Yeah.
I'm glad.
I got that. Better.
So now the conventional way, or the conventional perforation charge, the normal liner, because we're trying to talk about the reactive liner, which is our unique technology, versus the normal standard conventional liner.
Okay.
The conventional liner is made from copper. Copper. They use copper, they grind it into a powder, and then they press it. So when the explosion happens, it makes a jet and it goes inside the formation.
Okay.
But that ground copper stays in that tunnel, in that opening.
Of course, yeah.
Which is preventing more and more liquid coming in.
So it's ultimately like a bit of a plug, basically?
It's like plug. Exactly. We use the same word. We use the perforation is plugged.
Really?
And it's plugged because of the copper.
Okay,
Maybe you should consider a career in the oil and gas now.
I doubt that.
So the reactive liner is the technology that was actually developed by a military R&D center or company in the United Kingdom. It's called Kinetic. What it does, when this explosion happens and the tunnel is made, it has a mechanism. I won't go deep into it. It's a very interesting mechanism, but it gives you a very clean tunnel. So it takes all this debris back into the wellbore, and you have more flow coming in. Make sense?
No, of course. So no plug happening there then.
There's no plugging anymore.
Okay.
So that's the reactive liner.
And then the second type of technology that you mentioned was the steam injection profiling.
Yes.
So walk me through this technology.
Now, this technology in particular, we developed. We spotted that there was a gap. Nobody had it. We developed it. We have a patent for it.
And how many people were on the team developing this technology? Walk me through how do you ultimately develop such technology out of?
So remember when I was talking about the butter and making it liquid, which is happening in Mukhezna field. We needed a technology that can work in this very high temperature. So we're talking about 300 degrees Celsius and above.
Wow.
Imagine, I mean, the boiling the degree for water is 100, right? And this is 3 times as much. Now, electronics, in our measurement devices, electronics, they can take up to 150 degrees Celsius. But in order to develop something that can withstand this high temperature and achieve the measurement that is required, we needed to do a lot of work in the electronic design, in the heat sinks, in the heat shielding.
Yeah.
So we were a total team, since you asked about the team. We were a total team of 4 from Oman and 3 from the United States. Actually, I identified a gentleman who worked in Bakersfield, California. He passed away, God bless his soul. But he got together with us, understood from our perspective what is the need, what is the challenge. And there is actually that technique was used in California before, but we wanted to introduce a brand new approach to it. So he put together with us a mechanic guy and an electronic guy. And we did the first prototype. When we brought it to Oxy, Megan, they saw the quality of the data that we acquired.
Yeah, they were undeniable.
They were amazed because they used some other technologies before us. They couldn't get a fraction of how good the quality of our product or our service was. To the extent that actually we were thinking that we will be doing maximum of 16 wells per month. We ended up doing 60 per month.
Wow.
Yes, and that was an important part of the Falcon journey and its growth, actually.
Of course, establishing yet again that identity and that presence.
We remained the only provider of such service in the region, I think in the world, with that advancement. Until maybe 2016, 2018. I'm talking about from 2009 to almost a decade. We were the only ones doing it. And we are still in the leadership position when it comes to that technology.
I'm very sure that specifically in the region as well, you've been approached by several different companies and entities to provide these services outside of Oman as well then.
You are absolutely right. Yeah. I mean, there are fields in other countries like Kuwait and Saudi that are heavy oil. The butter example, remember, they called butter? And they need this technology. So we have been approached by companies from Kuwait, from Saudi to bring this technology. And the thing is, in those countries, they are still producing the easier oil.
Yeah,
and they are doing what they call the unconventional, which is similar to the shale gas, shale oil. It's related to fracking. I'm not going to take you into a lot of technical details, but the steam injection profiling is not yet picked up to the right pace. But I believe when it does, we will be the first to be looked at.
Well, I most definitely look forward to your advancements with the steam profiling. Okay, so now when we talk about wellbore integrity, we know that this is extremely crucial. So can you share some insights as well as the technologies that are helping you for the recovery rate of the wells?
Okay, so the technology that I mentioned earlier is the oriented perforation.
Yes.
And the integrity here is related to leaving that fiber optic line intact.
Yeah, the line,
because the fiber optic is responsible for measurements that were not known before a fiber can do. As I told you earlier, a fiber optic is used for the telecom.
Exactly.
Because it's high transfer rate. Because inside the fiber, there is a laser. And the laser is the speed of light. Okay. That's why you get very fast rate of communication with the fiber. You're what, a Gen Z? I mean, I'm an old timer.
Please don't disclose my age.
We used to have a speed of internet that was in bits per second.
Okay.
Now you have it in megabits per second. So
Yeah.
1 million times the speed that we used to have back in the day in the early 2000s or late 90s. And thanks to the fiber technology. But guess what? They actually, the more studies they did in the fiber for the sake of the telecom, they discovered that the fiber actually can detect temperature at every half a meter.
Oh, that's interesting.
You never thought about fiber can do that?
No, of course not. No.
That was, back in 2012 when this emerged as, they call it distributed temperature sensing.
Okay,
And
distributed
temperature sensing, which is every half a meter you have a temperature measurement.
Okay.
And it even progressed further, and they could actually acquire acoustics, sound, different frequencies from the fiber. Actually, and this is also a distributed acoustic sensing. So you have DTS and DAS or DAS.
DAS. Yeah.
Actually, this is also used not only in the oil and gas, as we are going to talk about a little bit more, but it's also used in security.
Okay.
Mark Zuckerberg, the founder of Facebook.
Of course.
His house is surrounded with fiber lines.
No way.
Because that they detect if any acoustic change, then it is a security breach.
Oh, wow.
Yeah.
That's really interesting.
They use it also in the railway. They use it in the pipeline to detect leaks because it's a continuous temperature sensing or an acoustic. But what we do for the oil and gas, the oil company runs the fiber to acquire temperature data or acoustic data, and we want to keep the fiber intact. When we remember to produce, we need to perforate. So when we perforate, the conventional way, we perforate circumferentially,
Okay.
But now we have a fiber, we need to perforate away from the fiber.
Okay.
Make sense?
Yeah. More or less. I think after you explained it to me like 7 times, I'll finally get it.
It's all right. But, this way, when we detect where the fiber is, this is the technology. We detect first, and then we have like a robotics, downhole robotics, where we direct the perforation into a direction away from the fiber. This was not there before. We brought this. We did a lot of collaborative work and research with Shell in this.
With Shell.
Yeah.
Okay.
The Royal Dutch Shell.
Yes, of course.
You would know that because you are half Dutch or something.
Well, actually, I'm South African, but my brother has been living in the Netherlands for like 8 years. I speak a little bit of Dutch, and I speak Afrikaans. Okay. So it's like basically the same as
I thought
Dutch.
Afrikaans was a derivative of Dutch.
Yeah, so of course, it's Dutch, and then the product of it in South Africa is Afrikaans.
All right.
Yeah, so fun fact, for those of you who didn't know, I'm actually South African, not American. And of course, it cannot be easy implementing these cutting-edge technologies across different geologies and operations. So how are you managing that?
Okay, see, as I mentioned before, one of our advantages as a local company, a regional company, we know this part of the world really, really well. And we also, in our team, we have people whose background are, petrophysics, which is a specialization related to the geology and the rocks.
Ah, okay.
So their knowledge, one of them was describing himself as a rock doctor.
A rock doctor.
Can speak to the rock. So this local knowledge is very important. But we didn't stop there. We have collaboration with a lot of research bodies, including Sultan Qaboos University.
Oh, very interesting.
The Research Council. And as I mentioned before, we work with the technology makers, technology developers. I mentioned Shell a while ago, but there are other big companies and small companies that are doing a lot of research and development, and we work with them. Sometimes our role will be to do the trials for these new technologies. Because when you create a technology in the lab, you do your lab tests on it, you think it's going to work, but wait a minute, the ultimate test is when you take it and put it inside an oil well and see how it actually behaves.
Yeah.
Many of these technologies actually fail during the trial phase.
I can
And
imagine.
Falcon has done a lot of trials for new technologies. So we are actively responsible for the emerging of a lot of these interesting, unique technologies that changed the industry to a certain extent. We call them the game changers. Because we look at technology that can actually save the customer, our client, save them time and cost and improve their efficiency. And even beyond that, we want to look at existing assets, like existing wells, how to improve their productivity. Because some of these existing wells are declared dead. You know, a well is like a human being.
Yes.
I wanted to tell you about what we do is wireline logging, which is similar to what happens in the hospital. When you have a patient, the patient goes to the doctor doesn't know exactly, he will send him to conduct measurements, tests, MRI, CT scan, ultrasound. They will take their pressure and pulse and temperature. Our service is exactly the same thing, but we do it in the oil well.
So considered dead well, you go.
So the dead well. So like in the patient example, the patient is born, has a certain life, and then there is death.
Yes.
Wells are like human beings.
It's inevitable.
Every well has a name, has a birthday, has a life duration, and then it will die. But what we say here, wait a minute, you are not dead yet. There is a technology that can still give you a longer life.
Okay.
That we do that to the well, which is it's going to translate to production, further production for the oil company that we are serving, and actually less carbon emission, because if you save them from drilling an additional well to produce the same, then that's a lot of savings on the emissions that are contributed to the environment from drilling every new well.
No, of course. And just for curiosity, what would be the average span or lifespan of a well? Or is it varying?
It's varying. And, it depends on so many factors. The first one is the geology. How is the underground rock looks like. And just to give you a little bit of regional perspective,
Okay.
Saudi is the largest producer of oil.
Of course.
And the reason why, their geology was much easier to work with and extract oil from, and much larger reservoirs exist in there. And if you look at the whole GCC, Oman production is probably coming after. So you start with Saudi, and then you have Kuwait, Emirates, Qatar, and then Oman. Oman has a large area. It is the second after Saudi. However, the geological structure in Oman is a lot more complex
than comparing it to
the rest of the GCC. So it is, Oman is so beautiful, and it has a lot of features, geological features that you see on surface. Like, for example, when you drive to Nizwa, you see the Jabal Akhtar, you see
it's absolutely
the tipping.
Gorgeous. Yeah.
They call it the heavens of the geologists. And it's so beautiful. It has so many aspects of beauty, but the geology underneath is so complicated and so complex that producing out of it is very difficult.
Yeah. That's very fascinating. Okay, so on to the next topic, which I'm very excited to speak to you about, is the Go2Zero. So can you paint a picture of this, and how does it work? Walk me through the Go2Zero.
Okay, Go2Zero, first of all, is a sister company to Falcon.
Okay.
But it has a lot of the DNA and philosophy similar to Falcon. And what we looked at there is, we see that the commitment that Oman has made and the globe has made, every country said we will reach net zero by this year. This is the net zero mandate.
Yes, Oman's 2050, correct?
2050 or 2040. Yes. Some countries 2050, some countries 2040. But, and Oman is going full throttle in this
100%,
green hydrogen economy or green economy. And you know, if you think about it, the globe is in need of this transition. Why? Because we were just talking maybe before we started the interview about the number of floods you've been through.
Yeah,
Recently.
it's been a nightmare.
And you know, I see this in the news on a daily basis.
Yes.
I mean, we saw what happened to Dubai a while ago.
And it's not normal
In the
weather
airport
behaviors.
itself, you see that
No.
planes landing into a body of water.
No, it's not
And
normal.
yesterday, I saw on Instagram a post about a similar situation happening in South America, in Brazil. So this is a global phenomena. And the reason why this is happening is because of our carbon emission as humanity, as a global contribution. So we must do something about it. And from our perspective, you cannot reach that net zero goal like that or by just wishing for it. You will have to have some kind of technologies that will take you through a transition.
Yes.
So, for example, a lot of the carbon emissions that we contribute to the atmosphere here in Oman and in our industry is the power generation in the remote sites during drilling, in drilling rigs.
Of course.
Right? Because the drilling rig will go in the middle of the desert, find a spot, and then start drilling. They need a lot of power to support this operation. And to do that, they generate it by using diesel generators. And these generators produce a lot of carbon to the atmosphere. Now, the technology that Go2Zero was built on is actually a JV, a joint venture between us and a UK-based technology house called Geology.
UK-based.
They started out of a university in Bristol, and they did a lot of research. They get grants and awards, and they are doing a lot of projects for the railway, and in many other countries. Their objective is to do a conversion. What is the conversion? We'll try to simplify it. So the conversion is a device you put inside this existing
Power
generator,
yes.
and then you bring another fuel. So another fuel that has less carbon content.
Okay.
This other fuel could be LPG that you use for cooking.
Okay.
It could be LNG, which is liquefied natural gas, which is part of what Oman is producing. And there is the CNG, the compressed natural gas. But there is also a new hydrogen derivative called blue hydrogen.
Blue hydrogen,
which is also, there was a lot of work and development from the Shell side and how to, and I believe we will see it being produced in Oman soon.
Okay.
This device,
fantastic.
This device taking blue hydrogen and the original diesel, it starts compensating. So instead of using diesel 100%, after it starts making power, it starts reducing the amount of diesel and increasing the amount of gas.
Ah, okay.
So this way, the overall output, carbon-wise, will be less. We will help in the decarbonization. Decarbonization, people who are idealists think of it as zero carbon. But in my opinion, in my approach and definition, I say, if you are reducing and helping in the transition, it is still under the umbrella of decarbonization, in my opinion.
Okay.
So this is what Go2Zero was built on, and it took us a little bit of brainstorming to come up with the name, and we say Go2Zero because zero is the ultimate,
the goal too.
The goal, but we have to go to it. It takes a journey. It takes a pathway.
Yeah.
And the other very interesting project that we are working on in Go2Zero is waste to energy.
Waste to energy.
So we can take waste, like fish waste or dairy farm waste, and using a technology that actually produces gas out of this usable gas that can be used to make electricity, power. We can actually use this gas, we call it biogas, in our dual fueling apparatus that we invented, Gevolution invented. So this is, again, this was a complete waste that was going into the environment, dumped in the environment. Now we are reusing that. This is part of what circular economy is all about.
Of course, yeah.
And actually, one of the byproducts you take, for example, in dairy farm, you take the cow manure, You do the fermentation process, you produce gas, you can use it to make energy, and it actually becomes a fertilizer where you can use it to plant crops to feed the cows.
Exactly, it's a full circle.
It's a circular economy. So this is what the aspiration is. We are still marketing and promoting the technologies, and I'm very optimistic that we will be making a breakthrough in the very near future.
And with regards to the Go2Zero initiative that you have, how easy is it for the existing generators to use the alternative fuels, basically?
This is the heart of the invention of what I told you about these scientists did in Bristol University, is to do that, what we call a control unit. A control unit is a retrofit that is added to the existing generator. And this is the beauty of it. You don't have to build a generator, a new one.
You just add this on.
You just retrofit it in an existing generator.
That's genius.
Because imagine if you come and tell all the drilling companies you have to change all your generators and bring the new ones.
No, it's
a waste of assets and capex.
And I mean the financial impact that it's going to have on companies.
Then where are they going to go?
Exactly, they're going to end up on some rubbish site.
Or they are going to produce energy at high carbon emission.
Yeah, it's a
so the best way is to come to existing fleet and then retrofit it with this technology. So to answer your question completely, is that control unit, which has some kind of a machine learning or artificial intelligence in a way. It's built on a software that is doing this, exchanging the diesel and bringing the other fuel. And the other fuel is through an injection system. It's an easy retrofit. It is very doable cost-wise. And we are looking forward to do the proof of concept soon.
That's incredible. And also, just to finalize and summarize this episode, looking ahead, looking to the future, what can we expect to see from Falcon? What's on the horizon for you?
Yes, there are a lot of things that we are
clearly, evidently.
There are a lot of things. Today I was talking to developers. There is a project that is going to be using AI for the first time in our application as a local airline logging company. So AI is definitely something we are looking into, and we are going to bring it about. We will continue in the digitalization journey for the company, and also we look at ways further to contribute to the net zero journey and the decarbonization.
But something that's very important for me is I would like to know if you have, a quote or an inspirational saying for the young viewers who are watching this, maybe potentially busy with their electrical engineering degrees. What word of advice would you give to them if they're considering going into the oil field sector?
Oh, that's a very important one. I always encourage our young students. I gave lectures in the University of Sultan Qaboos, and we Falcon we bring a lot of students. We show them technologies. We give them some kind of an inspiration. But for anybody who wants to come to the oil field industry, the high-tech sector where we are, you got to be inquisitive. You got to have curiosity. Don't just get to understand, okay, this technology does this, but ask how. Understand, the
deeper
workings of it. Because when you do that, then you can excel. You can find solve problems, which is the main objective of an engineer, is to solve a problem.
Yeah.
And also you can improve it further. You can make it do a better job, or you can make a new invention altogether to replace the older technology. So be inquisitive, be curious, ask how does it do it. That's what I say.
I really admire that, and thank you for sharing this quote with our viewers and with our listeners. Mr. Ibrahim, it is very evident that your driving passion for change, in this sector. It's remarkable, and it has been such an honor sitting with you today. And thank you for sharing the amazing work that you're doing at Falcon. I really appreciate it.
Thank you, Megan. I appreciate the great research and questions that you have put into this, and that gives me the confidence that this will be one of the landmark podcasts in the region.
Thank you so much. I look forward to it. I really do. And hopefully you can be my 100th episode guest as well to celebrate this.